Hi viewers, this is me Slasher and you're watching educational channel Slasher Education. So guys, today we are going to begin this book, the Nelson Mathematics for A-level students of pure mathematics. So we are going to start the chapter 1, which is Algebra. This is our very first chapter, and this chapter includes some variables, constants and the quadratic expressions which we use to divide by the other quadratic and might be linear expressions. So our very first topic is dividing polynomials by linear or quadratic expression. Let me tell, I will go through this book according to each and every topic of this book, and I will skip which the topic is not important one. So before we start this, we should aware of what are the constants and the variables are. Constant means same or equal. It means if I have a natural number 5, it is a natural number. Here, it is same in USA, it is same in Australia, it is same in Switzerland. I mean everywhere it is constant. But this is x. Suppose if you have a linear function, this is not our topic, but just to teach you, just for the better understanding, f of x is equal to x plus 3 or y is equal to x plus 3. This is a linear function and it will give you a straight line graph. This is if you have this variable, you will not change the constant. The constant will remain as it is. If you go through the question. But the value of x or y will be changed because they are the variables. It means that variables are those numbers, those quantities which are changeable, which are not constants. It means they could be changed. If I take the value of x is equal to 1 here, I can take value of x is equal to 2, and this changes the value of y. But the constant will not change. It means 3. Alright then, now we should know that what are the fractions. Well, I told you that I will go through the book, and they try to conceptualize the concept of the improper and the proper fractions. So what are the improper fractions? Let me tell you, you should be aware of the numerator and the denominator first. Suppose this is the room in which you are sitting at now. Okay, look at the roof. And just imagine a straight line in the space. Suppose just this point to that door. Okay, and now just consider that the ceiling is the numerator, and I'm denoting that with n, and your floor is denominator, and I'm denoting that with capital D. Right? Ceiling is numerator and the floor is denominator. This is the best way so that you can memorize it. Okay. If you notice that this fraction, well, actually this is a rational number. Rational number, it means in the form of p over q. It is a rational number. If you notice that the numerator is greater than the denominator, it means numerator is greater than the denominator. But if you look at the proper fraction, the numerator is smaller than the denominator. This makes the clear difference for the improper fractions and the proper fractions. If you want to express that in the polynomial form, it means which includes variables and the constants and the difference and addition sign as well, just like x plus 1 divided by x squared plus x plus 2. If you notice that this the denominator has more variables and a constant which is greater than 1. And in short, the numerator is smaller than the denominator. Hence, it obeys, it's a proper fraction. But if you reverse it, x squared plus x plus 2 divided by x plus 1. Now look at this, the numerator is greater than the denominator. Hence, it is an improper fraction. It obeys this now. Let me tell you the most confusing thing which I am still trying to conceptualize it. If you write this in this form, it is actually in this form. What will you get the answer? Actually, let me tell you. This is home. Well, I called it as home. You need to put the number at the left side in this, and this number outside, and now you're going to divide it as you learned in the 3 or 4 standard or grade. Now 4 ones are 4, and if you subtract it, we got this answer. Must remember, this is quotient and this is our remainder. And what about this proper fraction? 4 divided by 5. This means actually this. If you have scientific calculator, you can check this out. Now you need to put this in this home and put 5 outside of. Now you have to divide. As 5 is greater than 4, now you are going to multiply 5 with 0. Put a point here, imaginary point 40. Put a point here too. 5 into 8 is equal to 40. Now you have no remainder. Now what happened? If you look at this example, now we need to conceptualize the dividend, divisor and the quotient. Suppose I told you that this can be written in the form of this is equal to, we don't know its answer, but we can solve it. Now this is the dividend, this is the divisor, and whatever you answer is the quotient. Must remember, this is dividend, this is the quotient. Actually dividend is the amount you want to divide, and divisor is the number you selected to divide it by, and the quotient is your answer. Now I am going to solve an example from the book, from Nelson Mathematics, so that we could proceed further and have a better concept of it. Yes. We have an example of example 1a. Divide 2x cubed minus x plus 5 by x plus 3. If you write this in another form for better understanding, you can write this as 2x cubed minus x plus 5 divided by x plus 3. As I told you, the number at the left side is the numerator and the number at the right is the denominator. Hence, it is an improper fraction. So you can write it as this for more better understanding. So now you're just simply going to divide this. Put this expression in the home, 2x cubed minus x plus 5 and x plus 3 outside. Now what you are going to do to divide this completely, might not be completely because maybe it's not a perfect divisor of it. Alright then, you have a plus or addition sign here, so you are bound to multiply the variable and the constant one by one. Your first objective is to multiply a certain number with this variable, or might be a number, with that certain number or variable or a binomial or a monomial, so that it could be equal to this and they can cancel each other. Now if I multiply this x with 2x, 2x square, we know that the x square multiplied by x is equal to x cube, hence this makes 2x cube. Let me repeat again. If I multiply x with 2x square, it will equal to 2x cube as I write here. So this is just like an assumption we are going to do to just eliminate the first monomial for the further procedures. And now x has been just like eliminated, it is used already. Now I'm going to multiply the number 3 with it. Now I'm going to put this sign here, plus 3 into 6x square. The constant will multiply with the constant and the variable will not be affected by it. So I'm going to write 6x square Well, in the subtraction, of the expressions, I change the sign. Not I change the sign. Actually, it is in the mathematics that we are bound to change the sign. So if this is plus, this is going to be minus, and this is plus, and this is going to be minus. So they are same, and they are going to cancel. And nothing is like it, so it should be remain as it is. Minus 6x square minus x plus 5. Now again going to multiply this variable with a certain number so that the first monomial will be equal to that. But our concern is to make us equal number, just an equal monomial. A monomial is a term which contains a constant and a variable. So now I'm going to multiply this variable, it means x, with 6x. 6x multiplied by x makes 6x square. It means they are equal, but the signs are different. So I'm going to put this sign here. Now I'm going to multiply. It means I'm going to multiply x with 6x. And if I multiply this with this, it comes 6x square. Now I'm going to multiply 3 with minus 3x, it becomes minus 18x. I'm just going to change the signs, and my plus 18x minus x, plus minus is minus, so it becomes 17x plus 5. Now here's the maximum degree of the power is 1, and here is 2, so I need no variable anymore. I just need to multiply this term with the 17 so that the variable should be cancelled. Plus the same sign, plus 17. X multiplied by 17 makes 17x plus 3 into 17 makes 51. We're going to change the sign, this cancel, 46. So this is our quotient and this is our remainder. So the previous example which we solved was a linear expression which we used to divide a polynomial. But now we are going to divide a polynomial by a quadratic expression. A quadratic expression is in which the variable has maximum degree 2. It means the variable has maximum power of 2. So repeating the same processes, I'm going to put this polynomial in this home, 4x square minus 7 x square 3. The same process. Now I'm going to multiply separately and just pointing towards the signature. Now I need to multiply x square with that variable or with that constant so that the very first variable or the constant becomes equal to the. So if I multiply x square with x, it makes x cube. So I'm going to multiply this. X square with x makes x cube, and minus 3x, minus 3 multiplied by x makes minus 3x. So changing the signs, the very first variables are cancelled, but the remaining are 4x square plus 3x minus 7. Now I need to multiply this expression with that certain number so that it becomes equal. Now I need to multiply the x square simply by 4 and it becomes equal to it. Must remember here the sign which is here you need to put here. So here is positive, I'm going to write positive here. So 4x square multiplied by 4, it becomes 4x square, and minus 3 into plus 4 makes minus 12. So changing the signs, this cancels, and now 3x and plus minus is minus, so this becomes plus 5. Now it is solved actually. So this is our quotient and this is our remainder.